Hello everybody, I'm just going to do a quick video about how to do hand soldering of small pitch BGA, it's ball grid array, and wafer level chip scale packages. And these chips are generally fairly small, and one of the problems that we have is that, which I'll go through now, and is that they're really quite difficult to prototype for, and I'll show you the reasons why. So essentially you have to have a printed circuit board. Let's see if we can zoom in a little bit there. So we need to have a printed circuit board, and it pretty much has to be commercial, unless you're really lucky and you have an in-house setup which can do solder mask. If you ever tried to do BGAs without having a solder mask, well, don't even bother trying. It's nigh on impossible. It's key that the little balls, the little solder balls that sit on top of the pads on the chip itself, they will go everywhere without a solder mask. So you need to have some means of being able to do that. So pretty much forget about doing that in a rudimentary lab. Now you can get breakouts for BGAs and some WLCSPs, and these are available from a couple of outlets. So Proto Advantage is one, and also Chip Quick I see have started doing them. I'm not quite sure how long they've been doing them, but I've certainly got experience with the Proto Advantage ones. So they're pretty good, and certainly for large pinouts, pretty much, I'm afraid, large number of pinouts, you pretty much do need a PCB, unless you really are a bit of a sadomasochist. The other thing I should note though is that even with the breakout boards that you can get, there's pretty limited selection. So there are so many different ball grid array and WLCSP layouts that you're going to be lucky if you actually do get one. So is there a quick and dirty way of doing this? Well, of course there is, and that's what I'm going to discuss with you today. So what we're going to do is a very simple circuit. First of all, I'm going to do a little blinky LED, and I'm going to try and keep this as simple as possible. And what we have here is a Schmitt trigger inverter, which I remember doing these with the venerable old 7413 chip back in, oh dear, it would have been the 70s. And this for us was great because you could get an oscillator that was even simpler than a 555. The only thing about using the original 74 series, just to go slightly off topic, was that you had to keep a pretty specific resistor value to make it work, because the input impedance into the gate was really low. However, we're now in the CMOS land here, and the chip that we're using here got a very high impedance, so we pretty much can use any resistor we like here, and we can use any capacitor. But I'm going to make this difficult for ourselves, because I'm going to limit how big we can make this capacitor for this LED to blink. So I'm going to go for the biggest value capacitor that I have, but in the 0201 series of capacitor, and we'll see later how small that is. And the biggest I have in stock is a 2.2 microfarad capacitor. And so I did some quick calculations here, because we want to blink this LED, say at about 2 Hertz, and I'm going to give you this really approximate, very ballpark thing, that the frequency coming out of your Schmitt trigger is approximately 1 over RC. So with a capacitance of 2.2 microfarad and one frequency of 2 Hertz, I've got about 220k. And there's the output of the Schmitt trigger. And I made well, it would have worked, but I had to increase the resistance on here, because the maximum output of this particular series of logic, which is the AUP series, this has a maximum recommended output current between plus and minus 4 milliamps. So popping at 3.3 volts, popping a 470 ohm resistor in there, There's because the voltage of 1.6 volts across this LED, we're going to put in here this 470 ohm resistor at 1.7 volts. So if you calculate everything out, you get about 470 ohms is the closest common value that you use on there. And just to make life interesting, we're going to make the resistors 01005, which is even smaller than 0201. These are imperial sizes, by the way. I don't know how they work out in metric, but anyway, just to, I'm using the old, the imperial measures, not necessarily old, because people still use them. I think probably more than the metric a lot of the time. So the two resistors are going to be 01005. The LED is going to be a 0201, like the cap, so very small. And we're going to get on with it and build it. Just one thing here. I've got the bottom view of the BGA device. This is a 0.76 by 0.76 millimeter BGA device, and it's got 4 balls on it. And I've given the bottom view because the way I'm going to do this is, rather than put the balls down on the board, I'm going to have the balls facing upwards. So this is actually the bottom view, and this is going to be quite important to us when we actually come to doing the board layout, which we'll do on the fly. I'm not going to sit around too long and procrastinate about how I'm going to wire this up. But the first bit we're going to do is we're going to basically break out the board onto a bit of board, and I'll show you the stuff that I do. This is the stuff. Probably going to need to zoom in a little bit. This is another device that I did. It's not the one we're about to do. It's a little bit more complicated. There we go. This here is a breakout. This was actually a 12 ball device that I had to break out, and hopefully you can see that. And this board here is it's 50mm pitch, so that 0.05 inch pitch pads on here. So it's half the linear dimension of the sort of standard 0.1 inch pitch. And okay, so let's get to it. So we're going to solder some chips on today. Now this is going to be a BGA chip, a ball grid array chip, a small one, just a 4-pinner. And I'm going to just show you the sizes of these things. So you'll see here, here's an 8-pin dip device, which is humongous in the big scheme of things. This is a SOT23 device, and I'm just going to get out the device that we're about to solder to show you just how small we're going to go. Okay. Move those out of the way just temporarily. I'm going to have to do this under the microscope. I might just zoom out a little bit. I had some coffee this morning, which wasn't the brightest of ideas. There we go, it's out, so I can see we're going to be flipping devices all over the place this morning. So this is our device that we're going to solder, the bottom of it. So if you're not careful, they do tend to stick to your tools if you're not careful. And to compare that with the SOT23 that we had, there we go, that's the SOT23. And just to make everything equal, here's the dip package. Now, yeah, I definitely had some coffee this morning. You'll see that this little device actually is about, well, you could fit, say, I don't know, 3 of these devices. These are less than a millimetre. You could set, say, if I zoom in a little bit on there, you can see that you could probably fit, well, probably 3 of those between the leads of this chip. So let's get on with it and let's do some soldering. So as I mentioned, one of the problems is that getting these little devices actually soldered down for prototyping, one-off unit testing. Either you're going to have to spin a board, and you'll need to use a board house probably, unless you've got in-house means of being able to do solder mask. The problem is that if you look on the actual device itself, you'll see there's some balls on there. Now those balls, unfortunately, if you try to solder them without solder mask, they just go all over the place. So without solder mask, you are wasting your time. I've been down that route, and it's not very successful. So what we're going to do here is we're going to use it. So typically when you see these devices, you'll see them this way on the board. You'll see them this way up, and that little dot there represents the A1 pin. So they're in a grid. So so for example, that's, I think it goes, is it A1, A2, B1, B2, I think that's the way it goes. So this is A1 anyway at the top. So that's where we know it's going to be. Now I'm going to put the chip on this pad upside down, and I want the A1 at this corner. So here we go. Let's see how we get on. And quite often when I've done this before, I forget, like I've just done now. So let's just try again. Is. I hope I've got that right. Keep convincing myself I have. Right, there's A1. That should go there. Now, if we try and solder wires to this now, it's not going to be well and good. I'm afraid it's not going to do very well, because the problem is with the surface tension of the solder and everything, this thing's just going to move around as we try to solder to it. It's going to sit on the end of the soldering iron. So we've got to do something else to stop this thing from moving. And what better than to use a bit of super glue? So I'm going to do exactly that. So I've got some super glue here, which is just the, I think it's the gel stuff. I think they call it, I'm not sure if they call it Gorilla Glue or something. Anyway, whatever it's, I can't remember what the name is for it. But I'm going to put a little bit on the corner here. Don't put a blob on the board itself. If you put a blob on, you can see it's some old super glue there. Oops. Squirted out a bit more than I wanted, which is exactly the reason why you do it that way. And then I get a really, really old pair of tweezers, which I don't really care about. And what I'm going to do is the position in which we're going to put this device, I'm going to put a tiny, tiny little bit of, zoom out as much as we can do. So this is with my rubbish. You see, these have been through the walls, these. I'm going to put a little bit, there we go, tiny little bit there. And we'll zoom in again, and there she blows. Come on, stick. Fortunately, it's also decided it wants to stick to my, there we go. That's it. So now we're going to put some wires on. So let's just see how we can. Oh yeah, and also you need to be using lead-free for this. I normally use leaded solder because it's just much easier to work with. Now lead-free solder such as this, why would I want to do that for this? Now the problem is that the solder balls that are already on the chip we're going to keep, and because of that we need to make sure that there isn't, I found if we just use leaded solder, there's a sort of alloy or eutectic mix or whatever it's called, I don't know what the word is, but anyway the mix of the metals actually makes quite a brittle scenario. So you might think everything's fine and dandy, but then the next time you go and have a look at it a day or two later, you'll realise that half the connections are not actually there. So also what I'm going to do is I'm going to be putting, basically I'm going to be running wires from each ball to each around here. Now I've just put the end of the solder into the super glue, which wasn't really what I wanted to do. So the good news is this super glue disappears with heat, but I'll just put it on exactly where I didn't need to. Let's let it dry off, and I'll scrape it away with my... In fact, if I just heat it up, it'll probably be alright. I'll do the other ones while we're waiting. So it's going to put a little bit of flux down now. Unfortunately, it's almost impossible to put the amount of flux that you want down when you're down at this level. So you're just going to have to just dab it on gently and see how we get on. Okay, so there's one pad, there's another pad, and there we go. There goes our super glue. Don't breathe in. So the next bit is we want to run some wires from each of those pads. So what I've got here, if you can see, is I've taken some stranded wire, and inside the strands are only 0.1 millimeters. Now that's okay, but we do need to tin them first. If we don't tin them, it's going to make life quite difficult. So I'm going to see if we can tin these under the microscope. Okay, good start. Looks like we've still got a fair amount of flux knocking around. Now, this is the first time I've used some of these soldering irons today, so I just need to make sure that the tip ends are nice and wetted. And now let's see what we can do here. Hopefully the coffee scenario isn't too bad, although it's feeling pretty bad at the moment. Oh man, this is terrible. This is not the way it normally goes. I've definitely had way too much coffee this morning. Normally I can just dab it on. So if we're not careful, we're going to lose that ball. So there we go. So there's our first one. Yeah, this is the worst. What you do find is, in fact, as time goes on, you seem to sort of relax a little bit more, and things seem to go rather more to plan. Okay. I'm going to try a method again now of I strongly suspect I'm out of frame. I was out of frame, wasn't I? There we go. So normally I go straight onto the ball, but I'm a little bit too shaky for that today. For some bizarre reason. Well, I did have a pint of coffee this morning, so that's going to do it.
Oof. Don't think that's going to be enough, is it? Let's just give it a little bit more length there. Okay. There we go. Now, one thing I did do before I started, which I should have mentioned, was I made these little score marks here, which was where my A1 pin is. So that we can use in order to be able to figure out how else to make up this board. So A1 here, this is the input, I think. I need to get my paperwork out here. Right, I've got my paperwork out, so I'm going to start doing the wiring up. So first of all, we've got a capacitor from A1 down to ground. Ground is on B1, which is this pin here, so I need to run a wire down to ground and also around to here for the capacitor. I've got a resistor as well, which goes round to here. So let's see. Let me run the capacitor first, down to ground. So these are pretty handy. These are kits, and you can, I think they're about $50, and essentially you just end up with every single part you could think of, or sorry, reasonable. They tend to not be the whole sort of E96 thing. They're maybe the E24 or subset of E24, but you get reasonably good values. So let's just zoom out here and see what the size of these things are. So these are 0201 capacitors. So you see that the problem, these will disappear down these wires if we're not careful, so just bear that in mind. You don't really want that to happen. So, got my horrible old tweezers there. This, by the way, is I'm using a Hacko tip, a 0.2 millimeter Hacko tip. I think it's the S series. I'm not very into the Hacko stuff. It's not a Hacko iron, it's an El Cheapo iron. I think I picked it up for about $60 or $70 for an iron like this. I've had this for probably 6 or 7 years. I've changed the bit a couple of times, but it takes Hacko bits, and it's amazing. Mine's called a Psyche 898D. It has a hot air iron as well, with a selection of hot air tips. Amazing value, and so that's what I tend to use. Okay, so that's our capacitor, which is going down to ground. We're going to need I'm going to put the grounds in a moment. We're going to need a couple of resistors. Actually, I'll tell you what I do need as well. I need to put a decoupling cap in. I didn't put that in the circuit diagram, but let's stick in a decoupling cap, shall we? As we have our capacitors out. There we go, just flopped out. If we get through the entire video without me losing a part, there'll be a round of applause from me. You just have to accept you are going to lose parts, I'm afraid. That's just the way the nature of the beast. So this is going to go from VCC to ground. Now this is our VCC pin, which is A2. Oops, I'm making a bit of a pig's ear of this. There we go. I'm going to run some grounds now. So you may have seen this. You might have seen this tool before. This is it's a Kynar wire. Which used to be used for what do you call it? What wire wrap. That's it. It's on the tip of my tongue. But the good thing is that the wire is silver plated, the Kynar wire. And they're very easy to strip with these little tools here, and I find it great for using for wiring up on these little boards here. And so we're going to be doing a couple of wires now. One's going to be going through from there to ground, which is our VCC. Bottom of this board, by the way, is a solid ground plane. So this is, you'll see in a moment. When I take this thing apart, what I'm talking about, it just saves you having to, making a right old pig's ear of this, aren't I? People are going to be questioning my soldering skills here. I know I do. So you notice I also have some other irons here. I've got a couple of wellers that I'll be using. Oops. Now, that Hakko, oh dear, that is terrible. I'll just pull the pad. It's not going well today, is it? Let's just get some flux on there. It's not a big deal, that particular pad, but I'm obviously making a bit of a mess of things one way or another. There we go. Nothing like a bit of flux to clean things up. Yeah, the Weller tips are a bit more stubby, as you can see, rather than the Weller tip. This is actually supposed to be a 0.25mm tip, rather than the 0.2. I find the Hakko better for doing the really small stuff, but the problem is that there's not enough heat gets to the tip, so hence that's why I'm using this other, the Weller. And also for tinning the wires, I've got an even thicker sort of chisely type bit which I use for that. Okay, so that's that one. Let's also, hopefully we'll do this one, but we'll hopefully do this a little bit better than we did the last one, which is going down to ground. And we've got one more. This is the actual ground pin of the chip. This time I'm going to put some flux down. Now, I can't recommend when you're, even on these pads that I've broken the BGA out to. I don't recommend you stay on there for more than you know, a second or two, because otherwise you're likely to pull the carefully made connection off your device. So that's that. I think that's all the ground connections we're going to need to make. Bit messy at the moment, might tidy those up in a sec. So next thing I'm going to do is I'm going to swap this round and we'll solder the ground. So here you go, this is the ground plate that I was talking about, and for this you're going to need a decent bit. Having this ground plane is great for doing high-speed stuff, prototyping high-speed stuff. Right, and back round to where we were. Stick it the other way. There we go. It's looking pretty messy, actually. Let's put some flux in and tidy it up a little bit. Let's get the last resistor on. In fact, we've got 2 resistors to put on an LED, haven't we? So I need an LED to. I'm going to have to put another ground on, aren't I? An LED to go from ground to here, and then a resistor to go from down to that output to here. So we will need a 470 ohm from there to there. We also need a 220k, which is going round to here. Okay, let's get the resistors out. Okay, so here's a couple of resistors. So there's a 220k. Get some decent tweezers. So you might be able to see that these are even smaller than that. There we go. They're even smaller than those 0201s that we were doing a moment ago. So there we go. Oh, wrong iron. That's one, and we need a 470 ohm, which is for our LED current limiting resistor. Come on. Okay. There she blows. Again, very, very quick in and out. Actually, I'm not going to. Actually, I could put there. Okay, I'm just going to solder up this. Right, need some more flux. There we go. Let's get an LED. There she is. Okay, nearly lost that one. So the question is, which way does this go round? Well, good question. So I know which way round this goes. Basically, the one where you see the bond wire coming off, just here, I'm not sure if you can see that. There's a bond wire coming off here, and that goes to the more positive. So I always get mixed up. Do you know what? I've been doing this for nearly 40 years, and I still get confused as to what anode and cathode is. But basically, make this LED light. You want the one where the bond wire ends up going to the more positive. So I have this sort of anode cathode dyslexia. So I know which way round it should be, looking at the symbol. But would I be able to tell you which is anode and cathode? No. Okay. Now I'm going to have to run another one of those wires, Kynar wires through. Possibly doing this wrong way around. Probably should have put this in first. Okay. In fact, I'm starting to wish I didn't do it this way at all, because I've had problems with getting the these 0201 LEDs. There's no visibility from the top of this. Is a right old mess. I tell you what, I'm going to do that for now, and then we'll clean that up later. The problem is that the pads aren't very visible. They're not castellated round to the side or easily visible anyway, so it makes it quite difficult to know whether it's connected. So I'll probably stick a multimeter across there and see if it lights in a moment, just to see if we can check that it is making connection to that ground there, because it doesn't look too great to me. That I might put some more flux on it too. There we go, there she is. That looks a right old mess, doesn't it? Stick some flux on there and have another little go at that. What a mess. Dear, dear, dear. I've lost another pad. You couldn't make this up, could you? we go. That's killed it. More flux than you can throw a cat at. I'm not at all convinced that this is connecting to that pad. It's a right old mess to me. Shall we try it? Stick the meter on. Yeah. Definitely lighting up. Okay, so that means that any of these grounds should be okay for that. Including this one around here. Well, the next thing we've got to do is remember that we have this 220k resistor, and we've got to run a little wire around to the other side for that. This is the feedback resistor. So for that, I use this stuff which I've been using this for years, certainly since the 70s. I'm not sure if it's always been. It used to be called Vero wire, but I think there's some place called they're called Roadrunner, I think, who makes it now. So we're going to run this round from this pin here all the way around to, oops, yeah, just this pad here. Okay, so to do that I'm going to need to tin each end of the wire. There we go, that's one bit. You'll notice I went to the bigger iron to get this started. The reason for that is purely that you need to get a bit of heat on there. Oops, I'm making a bit of a pig's ear of this. There we go. That's that. It's going to go all the way around to just there, so snip it off. Now, rather than running this stuff off the reel, I recommend you take it out in sort of 6-inch sections and just use that, because the thing is if it's on a reel, you end up getting yourself in knots trying to undo it. So again, tin the other end because this tip needs wetting. Okay, that's that. There we go. So I'm sorry about this. This is such a mess around here. This isn't much better either. Now, I'm going to see if it works. Now, I'm almost certain this isn't going to work, but we'll give it a go anyway. Let's see. I've got to set the current limit. Limit 50 milliamps. So why do I think it's not going to work? Well, actually I don't think I did the other end of that. Did I do the other end? I did. I couldn't remember if I'd done the other end of that ground. The reason I don't think it's going to work is that you'll see there's quite a lot of flux around here, a lot of flux residue, and I'm going to apply power anyway. So I've got some wire now which we can use to set up a positive terminal. Again, this is just Kynar wire here, so I'll just do a short strip on one end and a long strip on the other, so you can get a a clip on there. There we go, and we'll wire that up. To what should be the positive. Don't make too much of a mess of things. I'm going to pop some more, a little bit more flux on there. Doing way too much, never mind. And I'm going to tin the pad. There we go. So let's see if this works. Now, as I say, I don't think it's going to work because I'm afraid this looks to me like there's a little bit too much flux on there, which is could have an interesting effect. So let's grab the terminals. So yeah, so you see it's on all the time, this LED. Now I'm going to show you something. I'm going to zoom in a little bit here and I'll show you something interesting. Can you see that fizzing? So this is the flux and other contaminants that are just fizzing away here. And if I remove the power, show you, so you've got both in there. Oops, I'm moving this in a bit of a strange way. Yeah. So you've got the LED. So if I remove the power, it stops fizzing. Put the power on again, and it starts fizzing again. So why is that? Now the current is 2 milliamps, which is just basically LED current. So the question is why is it fizzing? Sorry, you can't see from there, can you? So the question is, why is it fizzing? So, well, this is because there's ionic contaminants in there. So, you remember that 220k resist? That's reasonably high impedance. So the problem is that 220k is being swamped by the impedances from going through these the flux, which is currently, well, as you can see, fizzing away there. So what I'm going to do now is I'm going to stick the board into, for 10 minutes, into a ultrasonic bath, and we'll come back again and we'll see if it works. Okay, so I'll put it in the bath, in the ultrasonic bath, and let's see if this thing is going to fly. So I've got my 3 volts or whatever it is, 3.3, I think it's actually 3 volts here, and I'm going to stick it on here, and hopefully we can see what's going on here, because I've got several cameras in the view here, so I'm not sure what you can see and what you can't, so I might have to just move some wires out of the way. If we can't, there we go, and stick it on, and oh, there we go, flashing LED. So that's how we that's how to do it. It's how to make a little BGA flash an LED. So just to go through the circuit again, and I think I'm going to stick it in front of this camera here. So this is our Schmitt trigger, and it's got an RC oscillator running at around about 2 Hz, LED, current limiting resistor. So this is the RC circuit, so I'm going to go through where all those components are. So if I zoom out, this is our Schmitt trigger, and this is the positive supply coming in, this is the ground, input to the Schmitt trigger, this is the capacitor of the RC circuit, this tiny little thing here, oops, this is the resistor, in the RC circuit, the 220k. This is the resistor, the 470 ohm, in the current resistor for the LED. Of course, this is the LED. And ladies and gentlemen, that's how you do hand soldering of BGA packages. I would say that if you start going to packages which are more complex than this, which is not hard because it's about as simple as it gets for a BGA package, and you start having to jump wires over existing wires, in general do the outside wires first and then worry about the inner ones and gradually go further inside. This isn't very scalable doing it this way. As you've seen, it's taken a bit of time. But anyway, thanks very much for watching. Bye now.